In this video, we'll consider DFT for linear filtering of long duration sequences followed by overlap and save method. Sometimes it is necessary to convolve a finite duration sequence with an infinite duration sequence. If input sequence is of long duration, that is the length of the input sequence is very high, that is long, but impulse response of the system is finite duration. In such a situation, the output samples are not available until all its input samples are processed. It means that suppose the input sequence is say x of n and the impulse response of the system is say h of n, where the length of h of n is very long and the length of h of n is finite. We can say it as length is small. In such cases, if we perform the convolution between x of n and h of n, as the length of x of n is very high, so the output or the system produces the output after a long time. So to speed up the process, long duration sequence is divided into small blocks. That is, here x of n is long duration sequence. We are supposed to divide this into small blocks and process each block. That is, processing of each block means each block is done convolution with h of n using DFT, and finally combine the output sequences taking output from each block. So this process can be done in two ways. One is known as overlap and save method. Another method is known as overlap and add method. So in this video, we'll study overlap and save method. Now we'll consider overlap and save method. This method is used to perform the convolution between finite duration sequence with infinite duration sequence. Here infinite means long duration sequence. Now we'll see how to perform overlap and save method. Let x of n is input sequence and we'll assume that the length of this sequence is ls. Also let h of n is impulse response of the system. We'll assume that the length of h of n is say m. So we know that y of n will be equal to x of n convolution with h of n. So here x of n is long duration sequence. I will assume the values of x of n as, I will write the x of n sequence in general. X of 0, x of 1, x of 2, x of 3 and so on. The length of this is say ls. So as per our discussion, now we are supposed to divide this x of n sequence into small blocks. That is, divide x of n into small blocks, say x1 of n, x2 of n, x3 of n and so on. Now we'll assume that the length of each small block is capital N. Let n is length of each small block. So I can write n is equal to L plus m minus 1. From this we can get L is equal to n minus m plus 1. So here n is the length of each small block, m is the length of impulse response of the system, that is h of n. Shortly I will come to L. I'll tell later, I will explain what is this L. Now we'll see what each small block consists of. That is, I will take the first small block x1 of n. x1 of n will be equal to so x1 of n begins with zeros, that is, it consists of m minus 1 zeros, and we know that m is nothing but the length of h of n, followed by x of 0, x of 1, x of 2, x of L minus 1. It means that it consists of L, that samples of x of n. So this is the content of first block. That here the length of each small block and h of n should be same. The length of h of n is also made equal to n by adding L minus 1 zeros. That is, length of h of n is made equal to n by 0 padding. So here x2 of n will be x of L minus m plus 1 x of L minus 1, that is, it is nothing but it consists of last m minus 1 samples from x1 of n. That is, here we have written x1 of n. Last m minus 1 samples must be rewritten in case of x2 of n, and it is followed by again L new samples of x of. So here we can see that L minus 1 samples of x of n already we have taken from x of n. So now remaining, that is next L samples of x of n is to be considered, that we supposed to use in next block. That is, here this block is followed by x of L x of L plus 1 and so on till x of 2L minus 1. So that is nothing but L new samples of x of n. So number of blocks is to be continued until all the samples of x of n is completed. The blocks is to be continued until all values of x of n is considered. So next we supposed to perform the circular convolution between each small block with h of n. Now compute y1 of n, which is nothing but the circular convolution between x1 of n and h of n, that is x1 of n, h of n. Similarly, perform the circular convolution between second block, that is x2 of n with h of n, and this process is to be continued. The last step is m minus 1 samples of y1 of n, y2 of n, that is m minus 1 samples of this y2 of n, and so on, are ignored, and remaining samples are filtered one after the other. To get final sequence y of n. Now we'll consider one example so that we can understand better. Using overlap and save method, compute output of an FIR filter with impulse response h of n and input x of n. Use only 8-point circular convolution in your approach. So here x of n sequence is given, that is x of n is equal to 2, 9, 1 and 3. Here x of n is long sequence. It consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is, the length of this sequence ls is equal to 12. And h of n is given, which is equal to 1, 2, 3. The length of h of n is represented as m, which is equal to 3. And here it is said that 8 indicates, that is length of each small block. It should be 8, that is given. So with the help of m and n, we can easily calculate L, which is equal to n minus m plus 1, which is equal to n is 8 minus 3 plus 1 is equal to 6. So the length of L, that is L, is equal to 6. So now, as we have discussed, we are supposed to divide each x of n into small blocks, x1 of n, x2 of n and so on. The length of each small block must be equal to n. The smaller blocks, let my first block be x1 of n. x1 of n must be equal to, here as I discussed, it consists of m minus 1 zeros. So here m value is 3. M minus 1 means 2 zeros. 0, 0, followed by, here written L samples of x of n. So L value is 6. So 6 samples of x of n, that is 1, this is 2, 3, 4, 5, 6. So these are the first 6 samples of x of n. Here, that is 2, minus 2, 8, minus 2, minus 2 and minus 3. So this is the first sub block. The length of this is 8. Similarly, now we'll write x2 of n. So x2 of n consists of last m minus 1 samples from x1 of n. So here this is x1 of n, last m minus 1 samples. M is equal to 3. So last m minus 1 samples means minus 2 and minus 3. followed by L new samples of x of n. So L new, that is L equal to 6 new samples of x of n. So in previous block we have considered till this value. So here the next 6 values are -2, 1, -1, 9, 1, 3. So now we have to consider these 6 numbers, that is -2, 1, -1, 9, 1, 3. So next block is x3 of n will be, x3 of n consists of last m minus 1 samples of x2 of n. So here m is equal to 3. So last 2 samples, that is 1, 3, followed by, as we said here, L new samples of x of n. Here we can see that all the samples of x of n is covered. So there are no samples, there are no new samples are available. So we supposed to consider it as 0. So we supposed to use 6 zeros to make length equal to 8. So these are the sub blocks x1 of n, x2 of n and x3 of n. Now here we can see that the length of h of n should also be equal to n, that is 8. It should be made 8 by adding L minus 1 zeros to the sequence h of n. Here the sequence h of n is 1, 2, 3. Now we supposed to add L minus 1 zeros, that is 6 minus 1 is 5 zeros. So this is new h of n. Next we supposed to calculate the circular convolution between x1 of n and h of n, x2 of n and h of n, x3 of n and h of n. That is, we will perform the circular convolution between x1 of n and h of n using matrix method. So I will write the column matrix, that is y1 of 0, y1 of 1, y1 of 2, y1 of 3, y1 of 4, y1 of 5, y1 of 6, y1 of 7. So this is the column matrix is equal to, so now we'll write the input matrix, that is x of n. So first write x1 of n vertically, that is 0, 0, 2, 0, 0, 2, minus 2, 8, minus 2, then we have minus 2, minus 3. Now horizontally write the same sequence in reverse order like this. That is minus 3, minus 2 up to this 0. That is minus 3, minus 2, minus 3, minus 2. Then we have minus 2, 8. Then minus 2, 2. Then we have 0. We have to stop here. So this will be the square matrix. So now this sample should be written here like this diagonally. Similarly, this 0 is written here, this 0 is written here, minus 3, minus 2, minus 2, 8, this is minus 2, this 2 should be written here, 0, this is 0, minus 3, minus 2, minus 2, 8, this is minus 2, this is 2, 0, 0, minus 3, minus 2, minus 2, then we have 8, minus 2, 2, 0, 0, minus 3, minus 2, then we have minus 2, 8, minus 2, 2, 0, 0, minus 3, minus 2, minus 2, 8, minus 2, 2, 0, 0. Then like now we have the column matrix, that is H of n. So here H of n will be obtained as, so here we have 1, 2, 3, the length of H of n, and each smaller block should have same, that is here the length of H of n is 3, it's supposed to be 8, so add 5 zeros, or we supposed to add m minus 1 zeros, that is 5 zeros. Therefore now I can rest all values are 0. 0, 0, 0, 0 and 0. Now perform the matrix multiplication between these two blocks. We have 0 minus 3 into 2 is minus 6, minus 2 into 3 is minus 6. Rest all values are 0. Because these all values are 0, I will ignore those things. So now multiply second row with the column. I can write 0 into 1 is 0, 0 into 2 is 0, minus 3 into 3 is minus 9. I will ignore the remaining zeros as these all are zeros. Now third row with column, I can get 2 into 1 is 2, plus 0 into 2 is 0, 0 into 3 is 0. Rest all values are 0. Minus 2 into 1 is minus 2, plus 2 into 2 is 4, 0 into 3 is 0. Then 8 into 1 is 8, minus 4, 2 into 3 is 6. Then we have minus 2 into 1 is minus 2, plus 16, minus 6. Then we have minus 2 into 1 is minus 2, minus 2 into 2 is minus 4, 8 into 3 is plus 24. Then we have minus 3 into 1 is minus 3. This is minus 4 and this is minus 6. Rest all values are 0. Which is equal to, simplifying, I can write minus 6 is minus 12, minus 9, 2, 2, 10, 8, 18, minus 13. Is y2 of n is equal to x2 of n, h of n. I'll write y2 of n sequence first as a column matrix. So now write x2 of n sequence vertically. Here we can see that x2 of n values are minus 2, minus 3, minus 2. Then we have 1, minus 1, 9. Then we have 1, 3. So now horizontally write the same sequence in reverse order. That is 3, 1, 9, minus 1, 1, minus 2, minus 3. 3, 1, 9. Then we have minus 1, 1, minus 2. Then we have minus 3. So now just write the diagonal values, minus 2, 3, 1, 9, minus 1. This is 1, this is minus 2. Similarly here it is minus 3, minus 2, 3, 1, 9, minus 1, 1, minus 2, minus 3, minus 2, 3, 1, 9, minus 1, 1, minus 2, minus 3, minus 2, 3, 1, 9. Then we have minus 1, 1, minus 2, minus 3, minus 2, 3, 1. It is 9, minus 1, 1, minus 2, minus 3, minus 2, 3. Finally, we have 1, 9, minus 1, 1, minus 2, minus 3 and minus 2. Now write h of n vertically here. H of n sequence is 1, 2, 3. Rest all values are 0. 1, 2, 3. So now we'll perform the multiplication between these two blocks. Here we'll get multiplication only with these three values. Rest all values will be zeros. Those I will ignore here. Multiplying first row with this column, that is minus 2 into 1 is minus 2, plus 6, 1 into 3 is plus 3. Rest all values are 0. I will ignore here. Minus 3 into 1 is minus 3. This is minus 4 and this is plus 9. Next we have minus 2 into 1 is minus 2, minus 6, minus 6. Then fourth row, 1 into 1 is 1, minus 4, minus 9. Then we have minus 1 into 1 is minus 1, 1 into 2 is 2, minus 2 into 3 is minus 6. Then we have 9 into 1, 9, plus minus 2. Then 1 into 3 is plus 3. 1 into 1 is 1, plus 18, minus 3. Then last row is 3 plus 2 plus 27. So simplifying this, we'll get, so simplifying this I can write 7, 2, minus 14, minus 12. Here we have minus 4, minus 1, minus 5, 10, 16, 32. So this is y2 of n sequence. So similarly now we'll perform y3 of n, which is equal to subblock x3 of n circular convolution with h of n. I will write y3 of n sequence, column matrix, y3 of 0, y3 of 1, 2, 3, 'So first write x3 of n sequence vertically. So x3 of n contains 1, 3, rest all are zeros. 1, 3, 0, 0, 0, 0, 0 and 0. Now write horizontally, write the same sequence in reverse order, that is like this: 0, 0, 0, 0, 0, 0. Last value is 3. That is, we are supposed to add 6 zeros and 3. Write this one here. This is 0, 0, 0, 0, 0, 0. This 3 will be written here. This 1 will be written here. 0, 0. This is 0. Here 3. Here 1. Rest all are 0. This 0 will come here. This is 0. This is 3, 1. 0, 0, 0. This is 3, 1. 3, 1, 0. Here it is 3, here it is 1. H of n is nothing but 1, 2, 3. Rest all are zeros. So now performing multiplication between these two, that is 1 into 1 is 1 is 0, plus 3 into 2 is 6, 1 into 3 is plus 3, rest all values are 0. Here we have 0, this is 0, 3 into 3 is 9. Next here we have 3 zeros and here rest values are 0. So here also will get 0, here also will get 0, and here also will get 0. So simplifying this, I can write 1, 5, 9, 9, rest all are zeros. So now according to the procedure, m minus 1 samples of y1 of n, y2 of n and so on are ignored or discarded, and remaining samples are filtered one after the other to get the final sequence. So here m minus 1 samples of each output sequence, that is here m value is 3, first two sequences, first two values, that is we supposed to ignore these two values, we supposed to ignore these two values, and we supposed to ignore these two values. Now I can write y of n is equal to remaining values we supposed to write, that is 2, 2, 10, 8, 18, minus 13, then it begins with this, that is minus 14, minus 12, we have minus 5, 10, 16, 32, then it begins with 9 and 9, 9 and 9. It's y of n.